Okay, good day once again. You are welcome to class again. Today we are looking at our set theory. Okay, so we'll be looking at some questions that are penciled down for today's class. So I want you now to invite your mates. Just share the video with them. Let them know the class has started. Okay, now let's quickly do that in a minute before we start the class. All right, I want to believe we must have passed the message across to everyone. All right, so before we start the class, now I want you to give a thumb to the class. Yes, to show that you are ready for this class and you support the class. Okay, give a thumb right away. All right, now let us look at the question we have on the board. Now you are giving calling U to be the set of x such that 0 is less than or equals to x less than or equals to 15, where x is a natural number and p is the set of x such that 1 is less than or equals to x less than or equals to 12, where x is a perfect square. Now we have q being the set of x such that 5 is less than x less than or equals to 9, where x is contained in integer. R is the set of x such that x is less than 6 is less than x and x is less than 14 and x is a composite number. And the last one, S, is the set of multiple of 5. Multiple of 5. Okay. Now the question is list members of sets calling you P, Q, R, and S. All right, so that's the first start we want to do. Now let's start by listing the first one, P. Now P is the set of X such that 1 is less than or equals to X and X is less than or equals to 12. So we want to list those elements that are equals to 1 and their 1 is also less than them and they are also less or equals to what? To 12. They are 1, 2, 3, 4, 5, 6, and so on. So these are the numbers that we want to list, which must be within the universal set. But then there is a condition given here. Now we are told now that x is a perfect square. Now do you know the implication of that? We are not going to list everything. So we list those that are perfect squares. So now let's do that now. Okay, so the list of the perfect square is 1, followed by what? 4, followed by what? 9, followed by 16. But you can see 16 is not in the universal set. All right, so P is the set of 1, 4, and 9. All right, so these are perfect square that lies within this range. All right, now I think we are also have to find the members of the universal set. Now let's quickly do that. Now calling U, okay, now is the set of x such that 0 is less than or equals to x and x is less than or equals to 15, where x is what? A natural number. So now we are going to list members of this set that are natural numbers. So that means 0 is not going to be inclusive because natural numbers are what? They are counting numbers. So counting numbers start from 1. So we are listing 1 to 15. So we have 1, 2, 3 down until we get to 15. So these are sets of the universal set. Now, these are members of the universal set 1, 2, 3 down to 15. Okay. Now, Let's move to the next one. We are asked to list set Q. Set Q. Now let's look at set Q. What do we have in set Q? Now set Q is a set of x such that 5 is less than x and x is less than or equals to 9, where x is an integer. Now integers are whole numbers, so the element I'm going to be listing here must be integer, must be whole number. Okay, so now I'm starting from, now the element I'm going to list, 5 must be less to all the elements I'm going to list now. So that means we have 6, we have 7, we have 8, and we have 9. 9 is inclusive because it's also equals to 9. All of this number now, 5 is less to them because 5 is less to values of x. And all of this number, they are less or equals to 9. Okay, so now let's move to the next set, set R. Set R. What do we have in set R? Now, set R is a set of x such that 6 is less than x and x is less than 14. So now if I begin to list members of this set now, so I have 7, 8, 9, and so on. Okay, I'm going to list everything. But then there's a condition here. X is a composite number. X is a composite number. So by the time I'm listing, I'm going to list only composite numbers. So now we need to understand what composite numbers are. Composite numbers are natural numbers that have more than 2 divisors. They have more than 2 divisors. So now, any element you are listing now must have more than 2 divisors. Okay, now let's start. Now, of course, now you know where we are starting from. You cannot list 7 because 7 has only 2 divisors. So we start from 8. We have 8. It has more than 2 divisors. Now, the next one, 9, followed by 10. We have 11. 11 have only 2 divisors. So I'm not listing 11. Yes. Next one is 12. What of 13? 13 has 2 distinct divisors, so followed by 14. Now, but we can't list 14 because the number we must be listing must be less than 14. So that means this is where we are going to stop. So we have this. So these are members of set of R. Hope you get that. Now let's move down to the next one. We have S. Now X is multiple of 5. Multiple of 5. Now we are listing multiple of 5. So let's begin to list. The list is 5, followed by what? 10, followed by 15, followed by, and so on, 20. But we must not go beyond the universal set. This is the universal set. We must not go beyond the universal set. So this is what we have. Okay, so we have done the first task. Now the second task is this. Find number of elements in P intersection Q. Number of elements in P intersection Q. Now, the first thing is to do P intersection Q. Now, P intersection Q are those elements that are in set P and are also in set Q. Now, let us list P intersection Q. So, what are elements that are here and also here? I think we just have only one, P and Q. Look at set P and set. So 9 is here and 9 is also here. So I'm listing 9. There's no other number. So we have this. So number of elements in set P intersection Q will be what? Will be 1. So you count the number of elements we have inside. So you have 1. So that is the answer to that. Now let's look at the second one. This is A. Now let's look at the B part of the question. Now you have to find number of elements in P complement. P complement. So the set of P complement. Now, what do we call P complement? They are those elements that are not in P, but they are inside the universal set. Now let's get that. Those elements that are not in set P, but are inside the universal set. Okay. Now, can you list all those elements now? So I want you to quickly do that now. Let me see what you have. P complement. This is set P. So now list P complement. Can we quickly do that? Okay, so I'm waiting for your answer in the comment section. P complements. P complements. Yes. P complements. We have gotten a set of P to be 1, 4, and 9. So what will the complement be? Okay, I'm waiting for your answer so I can see how about when you are giving me answer here. We have 2, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. Okay, I can see 2, 3, 4, 7 by Remilekun. Okay, yes, I can see 2, 3, 5, 6, 7, 8, 9, 10, 11. Okay, so let's wait for others to drop their answer. Okay, complement of P. Complement of P. So, okay. All right, we have 2, 3, 5, 6, 7, 8, 10. Oh, Zenob have retracted that. Okay. All right. Now we are doing fine. So now let's quickly do it together. I think that is very simple and a lot of us have gotten the answer. Now let's look at it. P complements. P complement are those elements that are not here, but they are inside the universal set. Now let's begin to list P complement. Now look at the universal set. We have 1 to 15. So we start with what? 2, 3. I will not list 4 because 4 is here. So I move down to 5, 6, 7, 8. I'm not going to list nines here. I have 10, 11, 12, 13, 14, and 15. So this is P complement. So number of elements in P complement. P complement. Number of elements. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer to that problem is 12. Okay. Now, before we do the last one in that question, now let's look at the way marks will be awarded to that. Okay. So let's see. Now, for listing each of these sets, members of this set, there's a block mark for that. B1, B1, we have B1, B1, B1 for this. Okay. All right. Now, for getting these elements, this set, we have A1. Okay. No, M1, sorry, M1. And for getting the answer, A1. Okay. So now for listing all these elements, we have M1. For getting the answer to be 12A1. Now let's look at the third one. Let's look at the third one here. Okay, what do we have? C R union S complements. Now that's what we have there. That's the last one there. So now the first thing to do here is to get your S complements. S complements. Okay, can we quickly do that? Give me your X complement. This is X. What will be the S complement? Now let's quickly do that together. Make sure you are participating in the class. It will help you. So what is X complement? S complement. S complement. Yes, let your answer start rolling in. S complement. Oh, S complement. Bamidele, I can see 8, 9, 12. Are you sure that is the answer? Olatunbosun, I can see 5, 10, 15. Are you sure that will be the answer? Okay. Yeah. Okay, I can see your Obasanya 1, 2, 3, 4, 6, 7, 11, 12, 13, 14. Okay, all right. I can see Abbas 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. Okay. Yes, I can see Show Me there. I can see your result. Shotayo, I can see you. Okay. I can see Rashida. I can see Zenob. Mujibat. Okay. That's a very good one. Okay. Yes. Now let's quickly do it together. There are some of us that are not getting it, while some are getting it. Right. Now let's look at it. Let's look at what we have here. Now, we want to get S complement. There are those elements that are not in set S, but they are inside the universal set. That's S complement. Very easy. Those elements that are not here. Just list all the elements in the universal set and skip 5, 10, and 15. That's all. So what you're expected to list is 1, 2, 3, 4. Don't list 5 because 5 is here. You move down to 6, 7, 8, 9. Don't list 10. 10 is here. Move down to 11. Don't list 12. You have 13, 14, and 15. Okay, so those of you that got this answer, you can clap for yourself. That's very good. That means you are learning very fast. Okay, and if you miss it, I appreciate those people that got the answer. All right, your time is coming where you are going to get yours too. All right, okay, so that is S complement. Now, can we do this now? R union S complement. R union S complement. Now, when we say union, that is, we bring together the two sets, all the members in set R and set S complement. We bring them together. Now, let's look at set R. Set R, we have 8, 9, 10, 12. 8, 9, 10, 12. So now let's begin to list. We have 1, 2. You are listing all this and you are including this. Okay, you include this with this. So we have 1, 2, 3, 4, okay, 6, 7, 8, 9. We have 10, 9 here, we have 8, okay. So, and 11, we have 12 here, so you have to list 12, 12, 14, and 15. Okay, so that is what we have here. All right, so I think we have 13, so it should be 13, 13, 14, 15. Yes, so that is what we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, that's correct. So this is the set of P union S complement. All right, that's the first part of the question. So we are going to be looking at another set of questions. So before we do that, now make sure you give a thumb, share this video as you are watching, share it with your friends now. Can you quickly do that and give a thumb? All right. Okay, so now let's look at the next question here. Rewrite 2, 3, 4, 5. That's number 1. In set builder notation. That's the first one. And let's look at the second one. list members of set of 2x such that minus 2 is less than or equals to x less than or equals to 3, where x is natural number. Okay, so now the next one, we write 2, 4, 6, 8 in set builder notation. All right, now let's look at the sets of questions we have here. Now the first one, you have to rewrite this in set builder notation. Now for me to rewrite, the first thing is I have to examine the set of numbers we have here. Now when you look at this set of numbers, they are set of counting numbers. So they are natural numbers. And also I can also look at them as whole numbers, that is, they are integers. All right, so these are also integers. So now if I want to write, there are several ways of writing this. Okay, so now I can write this as the set of x such that 2 is less than or equals to x, less than or equals to 5, and x is contained in natural number. Okay, or I write it this way, or I write the set of x such that 1 is less than x, less than 6, where x is contained in integers. So you have several ways of writing it. You have more way of writing that. All right, so that is the answer to the first one. Now let's look at the second one. Now list members of a set of 2x such that minus 2 is less than x, less than or equals to 6, less than or equals to 3, where x is a natural number. Okay, I'm going to do this for us, but I just need you to make an attempt. Try this and let me see if you can get the answer. We did something similar to this in the previous video. All right, so I want you to try this. Let me see what you're going to have. Now, can you list members of this set? I'm giving you a minute to try that. Try it, and after trying, we do it together. Okay. Anybody trying? Okay, I can see a result here. We have Suraja. I've dropped an answer for us here. 2, 4, 6. Okay, I can see that. Okay, let's wait for others. We have 2, 4, 6. We have 2, 4, 6. Okay, we have 2, 4, 6, 2, 4, 6, 2, 4, 6. Okay, 2, 4, 6. 2, 4, 6. Okay, I can see 4 to 6. All right. Okay, now I think I have a good number giving me the answer now. All right, so now let's look at it together because of our time. So make sure that you tap the like button. So I want you to tap the like button now. Please do that now. Tap the like button now. Now let's look at what we have here. Okay, so this is a set of 2x such that minus 2 is less than x, less than or equals to 3. Now, if you are to list members of this set, what we have is, without this, we have 1, 2, and what? And 3. You are not going to list minus 2 and minus 1 because why? We are interested in natural number. But you can see a condition here that all values of x should be multiplied by 2. So that makes this one, you multiply this by 2, and this by 2. So we have 2. This one will turn to 2 times 2, 4. This one, 3 times 2. This is going to give you 6. Good. So that means virtually all of us got the answer. Please give yourself a round of applause. That's very good of you. So that is the answer to that. Now let's look at the third one. Let's look at the third one. Now you have to rewrite this in set builder notation. All right. Now the first thing is that I have to look at the numbers I have here. So I have 2, 4, 6, and 8. Now what comes to mind is these are multiple of 2. Multiple of 2. I want to write this in set builder notation. So it's going to be the set of, now this is this general form for multiple of 2. You can have it as 2x. Okay? 2x. So I have 2x such that, 1 is less than or equals to x, and x is less than or equals to 4, where x is a natural number. Okay, so now that's what we have. So when x is 1, you have 2. When x is 2, 2 times 2, you have 4. When x is 3, you have 6. And when x is 4, you have 8. So this is going to be the answer to that problem. All right, so before I move down to another set of questions, I want you to try this and tell me the answer. Right, let's see. Okay, okay, so I want you to list members of this set. Try this. List members of set A. Okay, so we have A to be the set of x plus 1 such that x is less than 3, where x is contained in an integer or a natural number. So can you list this one? And I'm giving you another one. We have this x, so such that x is greater than 7 and x is contained in. Now let's do these two. Now let's first attempt this first one and let me have your answer. So what's going to be member of set A? Can we quickly do that? Set A, what is going to be members of set A? Set A. Okay, what is going to be members of set A? Can you list that? Okay, I can see 5, 6, 7, 8, 9, right? Set A. Okay, I can see 2, 3, 1, 2, can see 2, I can see 1, 2, right? A is the set of 2, 3. Okay. Okay. All right. So what I'm seeing here, I'm seeing more of 2 and 3. Okay. Now let's look at the first set. Set A. Now set A is the set of x plus 1. X plus 1. Now let me list members of this set. Members of this set are 1 and 2. So that's what I'm supposed to list. So this is going to be 1, 2. But then a condition is given. Look at it. X plus 1. X plus 1. So I'm going to be adding 1 to this and 1 to this. So this is going to give me 1 plus 1, that is 2, 1 plus 2, and that's going to give us 3. So this is what we have for set A. So those of you that got this answer, give yourself a round of applause. That's very good of you. Now, can we move down to the next one? B. Now let's move down to B. Now, the set of x such that x is greater than 7, where x is an integer. All right, so let's see. Let's drop our answer. What do we have? Set B. Okay, set B, we have 8, 9. Okay, so I can see your answer, Lekon. Agbode, I can see Olatunbosun. We have 8, 9, and 10 only. All right. Okay. Okay. All right. Okay. So now I can see that many of us are doing fine. Okay. Now, members of this set, set B. Now we have, this is set of x such that x is greater than 7. X is greater than 7. Now, integers that are greater than 7, they are 8, 9, 10, 11, 12, and so on. So you put dot. So it's an infinite set. So this is the correct answer. Those of you that have it this way, you can give yourself a round of applause. That is very good of you. And don't forget, whenever you are listing member of a set, you must always remember to put curly brackets. So if you just list now and you don't put this curly brackets, you know it's as good as scoring 0. So now always remember to put your curly brackets. So that shows that you are talking about a set. You are not just listing, you are talking about a set. So your curly brackets must be there. All right, so that's very good. Now let's move down to another question. Okay. Find all possible subsets of sets R equals to um, all possible subsets of set R equals to the set of X such that X is less than or equals to 3, where X is a member of natural number. Okay, you have to list all possible subsets of what we have here. Now, the first thing is to list member of this set. So we have 1, 2, and 3. These are members of this set. So all possible subsets of this. Now, the first subset of this set is an empty set. Okay, followed by one set of 1, next set of 2, set of 3, next set of 1 comma 2, set of 1 comma 3, set of 2 comma 3, and the last one set of 1 comma 2 comma 3. All of these are possible subsets of this. Now let's count all together. It must be 8. 1, 2, 3, 4, 5, 6, 7, 8. So they are possible subsets of this set. All right. So now, can you do this for me? Find all subsets, all possible subsets, all possible subsets of set 3. Okay. Can you list all possible subsets of that set? Yes. Now let me see that. All possible subsets of set 3. All possible subsets. All possible subsets of set 3. Okay. Yes. Abode have dropped an answer. Okay. We have 2. Okay. All right. We have okay, all possible subsets. Okay. All possible subsets. I expected everybody to drop answers because it's very simple. Yes, I want you to make an attempt. All possible subsets of set 3. All possible subsets of set 3. Okay. All right. Yes, you are doing fine. So now the answer is an empty set and the set 3 itself. Or you write this as empty set. This is another symbol for empty set and the set of 3. So this is going to be the answer to that. Okay, so we are moving down to application of set theory to 2 subsets. Application of set theory to 2 subsets. Now the first one, in an exam, 31 candidates, 31 candidates passed chemistry. Okay. 29 passed physics and 3 failed. 3 failed both subjects. If 50 candidates sat for the exam, how many passed only one subject? How many passed only one subject? Okay, now look at this question. Now, in an exam, 31 candidates passed chemistry, 29 passed physics, and 3 failed both subjects. If 50 candidates sat for the exam, how many passed only one subject? So how do we do this? Now, the first thing now is to list all the sets we have here. So you have let calling U represent all the candidates, okay, and C to represent set of those that sat for chemistry, P to be the set of those that sat for physics. Okay. All right. So now you can now draw your Venn diagram now to show all of this. So we have two subsets. We have set of those that sat for physics and the set of those that sat for chemistry. So the number of those that sat for physics, how many sat for physics? We have 29 pass physics. Okay, 29 pass physics. Okay, now this is supposed to be passed. Okay, not sat, passed. Okay, because we are talking about those that passed. Okay, all right, so P to be the set of those that passed physics, and this C to be the set of those that passed chemistry. Okay, hope you get that now. All right, so now P is the set of 29 students, and C is going to be the set of what? 31 students. 31 students. Okay, so all of these will be inside the universal sets. All right, the total number of the students that sat for the exam will be what? Will be 50. Okay, all right, now let's go through the question again. In an exam, 31 candidates pass chemistry. So 31 pass chemistry. This is the circle of those that pass chemistry. Now 31 pass chemistry, 29 passed physics, 29 pass physics. This is the circle of those that pass physics. All right, now, and 3 failed both subjects. Those that fail both subjects will not be inside this circle. They will be outside, 3 of them. All right, so now if 50 candidates sat for the exam, 50 start for the exam, that is the total number of the students is 50. So how many passed only one subject? How many passed only one subject? So those that pass this subject and also pass this. All right, now, so we don't know the number of those that pass the two subjects, so we can represent that with X. Now, those that pass only physics will now be 29 minus X. Those that pass only chemistry will be what? 31 minus X, right? Okay, so now when you add these 4 parts together, it's going to give you the universal set. So this is part 1, only physics. Part 2, physics and chemistry. Those that pass physics and chemistry. Part 3, those that pass chemistry only, and part 4, those that fail. All right. So when you add these 4 parts together, you equate it to 50. So we have 29 minus x plus 31 minus x plus 3 equals to 50. Okay, that is what we have. So now this is 31. All right, now so now let's join this and this. This and this will give you 0. Okay, so now let's add this and this together. We have 60. All right, 60 plus 3. That's going to give you 63. So we have 63 minus x equals to 50. All right, so we have x equals to 50 minus x equals to 50 minus 63. So that means minus x equals to minus 13. So therefore, x equals to 13 candidates. So 13 candidates pass the two subjects. So we have 13 that passed the two subjects. Now the question is, how many passed only one subject? Now what the question is asking for, those that pass only physics and those that pass only chemistry. So we now write that here, number of those that passed only one subject, will now be the addition of this and this. Now, when you add this and this together, you have 60. You have 60 minus 2x. Hope you get that. This and this gives you 60. Minus x plus minus x gives you minus 2x. So we have 60 minus 2 times x. X is what? 13. So that means we have 60 minus 26. Okay, so that's going to give you what? The answer is going to be 34 students. So that's going to be the answer. Okay, 34 students passed only one subject. 34 passed only one subject. All right, so I want to believe you understand this question. All right, so I'm going to give you similar question. We are going to try. So after trying, we looked at the question together under two subsets. Now let me write the question on the board for you. Okay, now let's look at the question. In a class of 35 students, 18 take 18 take maths and 11 take English. If four take both subjects, okay, now how many take none of the subjects? Two, how many take only one subject? How many take how many take at most one subject? All right, so these are the questions. So can you quickly try this in few minutes? Try this in few minutes before we solve it together. All right. So I want to believe large number of us attempt this problem. So let's verify whether it is correct. Now let's check. Now, before I solve this problem, I can see some of us are dropping one or two message based on what we have done. You see, now the unit can either be student or candidate. Students are the one writing exam. So if you have used students in place of candidate, it's still the same thing. Hope you get that now. So it is still allowed. Is that taken? So there's no problem with that. So once you use students, students are the one writing examination. Is that taken? All right. So now when it comes to the listing of those elements, so I think that 15, you can always adjust that. So that is a mistake. So I'll just correct that. It's good for, it's good that some of you called my attention to that. Okay, so let's adjust that. Now, let's look at the question we have here. So in a class of 35 students, 18 take maths and 11 take English. So if 4 take both subjects, how many take none of the subjects? Okay, all right. So now let's look at what we have here. So we are giving the total number of the students to be 35. So you can start by saying, let curly U represent the set of all the students. All the students. Okay, so if curly U is the set of all the students, so and then we have M to be the set of those that take maths, those that take maths, and E to be the set of those that take English. All right, so we can now go straight to the problem here. So now let's draw the two subsets. Now this is a set of those that take English, and here to be the set of those that take mathematics. All of them are inside the universal set, which is equals to what? That's 35. Total number of students is 35. Okay, now this first set is the set of those that take English. How many take English? 11 take English. So this is 11. Now let's look at mathematics. How many take mathematics? 18 take mathematics. So we have 18. Right? So if 4 take both subjects, so both subjects are here. We have English and maths here. So this place is going to be 4. Now the question is, how many take none of the subjects? So we want to know the number of students we have outside here. So now let us get the number of students that take only English. So what are we going to do? You have 11 minus 4. So that gives you what? That gives you 7. Okay, so now let's look at this. Now we have 18 minus 4. What do you have? You have 14. Okay, so the number of those that take English only, 7. The number of those that take both subjects, 4. And the number of those that take only mathematics, 14. Now we want to get the number of those that take none of the subjects. Okay, so we add the 4 parts together. This is part 1, part 2, part 3, and part 4. Now let's add the 4 parts together and equate it to the number of elements in the universal set. So you have 7 plus, for part 1, part 2 plus 4 plus 14 plus x equals to 18. So you can add these numbers together. So when you add, what do you have? So when you add 4 and 14 together, you have 18. So when you add 18 and 7 together, you have 25. Okay, you have 25 plus x, okay, equals to 18. Okay, now this one's supposed to be 35. Sorry, this is 35. All right, do you get that now? The universal set is 35. So we have 35. So we have x equals to 35 minus 25. All right, so the answer now is going to be what? 10 students. 10 students. So 10 students, 10 students take none of the subjects. Okay, so 10 students are outside. All right, so that is what we have there. Okay, now can we move down to the next thing here? So now let's move down to the next thing. Now the question says, how many take only one subject? How many take only one subject? Now it's clear here. The number of those that take only one subject, you add this and this together. Now only English is 7. Only mathematics is what? 14. So only one subject is the addition of 7 and 14. So number of those that take only one subject will be equals to what? 7 plus 14. That gives you what? 21. That gives you 21 students. Don't forget to put the units. 21 students. Okay? 21 students take only one subject. All right? So now let's look at the last one we have here. How many take at most one subject? Okay, so now can we do that now? Let me have your answer. How many take at most one subject? At most one subject. Okay, it's straightforward. You can look at it and get the answer. How many take at most one subject? Okay. How many take at most one subject? Oh, good. I can see somebody with the correct answer. So let me just wait for others to give their answer. Okay. Somebody have the correct answer here. Okay. How many take at most one subject? How many take at most one subject? Okay, I can see 21 students, 21 students. Okay, 21 students. I'm going to explain what at most and at least after this to I can see express service. Okay, so we'll explain that later. So how many students take at most one subject? I can see 21. I'm seeing 18, 21, 21. Now let others drop their answer. Okay, before we do it together. All right, 21, 21, 7. Okay, 31. Okay, all right. Okay, now let's do it together. Now, when I say at most, I gave you that illustration in the last video. Okay, the videos I've done, one of the videos I've done before. I said when you are asked to keep, once you are coming to school, make sure you have at most 10 naira in your pocket or $10 in your pocket. So at most $10. If you have 5 naira, you are still correct. If you have exactly $10, you are still correct. But if you have like $20, you are not correct because the question says at most $10. Okay. So, and if you don't have any money, you are still correct because you have not gone beyond the limit. The limit is bounded above. You must not go beyond $10. So the maximum is $10. But if I say at least $10, that means if you don't have any money, you must have $10 in your pocket or more. You can have $1 billion in your pocket if possible. So you are still correct. If I say at least $10, so 10 upward, that's the meaning of at least 10 upward. So in this case now, we have at most one subject. That is those that take one subject and those that do not take any subject at all. So very few of us got the answer. All right. Those that take one subject and those that do not take any subject at all. So in this context now, those that take at most one subject is going to be we're going to have 7 plus 1 plus 14 plus x. X is what? 10. So when you add everything together, you're supposed to have 31 students. So that is going to be the answer to that problem, right? So I want us to give it together. Let's give it to those that got the answer. Let's put our hands together for them. They have done very well. So I can see a few people giving me answer to be 31. So I think Bamidele also and somebody else gave me 31. So let's put our hands together for them. They have tried. All right. So that is where we are going to be stopping for today. All right. So tomorrow is another day. So we are going to be looking at 3 subsets, questions under 3 subsets tomorrow, hopefully. And also we look at some questions under algebraic processes. Okay, so I want to believe we all enjoy the class today. All right, so don't forget to always comment anytime we are online like this, and always remember to tap the like buttons. Okay, and also you share this video with your friends. All right, so thank you very much. Enjoy yourself and make mathematics to be a fun. Thanks and bye-bye.